What I'm going to talk about in this video is solving equations by factoring. The key idea that you need to remember is this. If you multiply two values and get an answer of 0, one of the values must be 0. For instance, if I multiply 5 times some unknown number, I'm going to call it x, and get an answer of 0, the only possibility here is that x equals 0. It's the only way to multiply two values and get an answer of 0 is if one of them is 0. This one's not the 0, so this one must be. But if I multiply two values that I don't know and get an answer of 0, I still know that one of them has to be 0, I just don't know which one. This could be the 0, or this could be. And so what we're going to do is based on that idea that when you multiply two values and get an answer of 0, one of those values has to be 0. But the values that we are going to be multiplying are going to be binomials. Like if I multiply x minus 2 times x plus 1 and get an answer of 0, what I know is that either this value equals 0 or this one equals 0. Because the only way to multiply two values and get an answer of 0 is if one of those is 0. And so what I do is I say, okay, those are two things being multiplied. That means that either the first one, the x minus 2 equals 0, or the second one, the x plus 1 equals 0. And then I solve each of those equations. Here I'm going to add 2 onto both sides and get x equals 2. Here I'm going to subtract 1 from both sides and get x equals negative 1. And so I now know that x equals 2 or x equals negative 1. And both of those are solutions to this equation, the original. So if I go up here and I fill in the 2 for x, that would be when x is 2, I get 2 minus 2 times 2 plus 1. That's 0 because 2 minus 2 is 0. Times 3, that gets me an answer of 0. So this solution checks out. X equals 2. When I plug in the 2 for x, I get a true statement. If my x is negative 1, when I take that, negative 1 for x, and plug it into the original equation, negative 2 minus 1 is negative 3, negative 1 plus 1 is 0, and when I multiply the negative 3 times 0, I get an answer of 0. So that answer checks out as well. And so the solution to this equation, what you're doing is you're solving to find all the values of x that make this equation true. The solution is this. X equals 2 or x equals negative 1. Remember, this part I was just checking to make sure that I found the correct answers. So let's look at another one. I'm going to erase this now. This time we're going to multiply 2x minus 5 times x plus 3, and that equals 0, so there's the equation, and I want you to solve this. Now it's already factored. I'm already multiplying two values and getting an answer of 0. So that means either that first binomial equals 0, or the second one equals 0. And so I solve each of these. In this case, I add 5 onto both sides, and then I divide by 2. And I'm going to leave the answer in improper form. Over here, I subtract 3 from both sides. And those are my two solutions. X equals either negative 3 or 5/2. And you can put your answers in set notation like this. So whenever you're solving equations that are already in factored form, in other words, you have two things being multiplied and getting an answer of 0, you just set each piece equal to 0 and solve. Now I'm going to erase this so I can show you another one. This one's going to have 3 parts to it. This time I'm going to be multiplying x times 2x minus 4 times x plus 7 and getting an answer of 0. So when I solve this equation, what I said before still holds true. If I multiply 3 things and get an answer of 0, it means that one of those expressions has to be equal to 0. So either the first part equals 0, or the second factor that's being multiplied equals 0, or the third one equals 0. So I take each of them, set them equal to 0, and solve. Now here there's no solving to do. The solution is x equals 0. Here I'm going to add 4 onto both sides, divide by 2, and get x equals 2. And here I'm going to subtract 7 from both sides and get x equals negative 7. So my solutions here are negative 7, 0, and 2. So now what happens is this: you might not be presented with an equation in factored form, as I've shown you here. And instead, I'm going to show you an equation that looks like this. Now in this case, you'd be stuck and unable to solve this, except we've been practicing factoring quadratics. And so I do that unfoiling process where I factor this. The x squared gets broken up into x and x. I have a plus at the end. When I have a plus at the end, that tells me I'm going to have two of the same operations in here, and they match the middle one. That means I'm going to have a minus and a minus. And then I'm looking for numbers that multiply to get me 2. I only have one set of options. Well, it's 2 and 1 or 1 and 2. So I'm going to factor it this way, and then I'm going to check to make sure I've factored correctly. So when I multiply this, x times x gets me x squared. That checks out. X times negative 1, that's negative 1x. And the inside's negative 2 times x, that's negative 2x. And when I put them together, I get negative 3x, so that checks out. And then when I multiply the last, I get positive 2. So the fact that I remultiplied them and got what I started with tells me I've factored correctly. Oops. And so from there, now I have an equation in factored form. I take each of them, set them equal to 0, and that gets me my possible solutions. In this case, x equals 2. And in this case, x equals 1. And so my solutions are 1 and 2. Now I can check my work by plugging the 1 into the original equation and seeing if I get a true sentence. So that'd be 1 squared minus 3 times 1 plus 2. And my question is, does that equal 0? 1 squared is 1, that's minus 3 plus 2. And yes, indeed, that does equal 0. And then I can check the 2 by filling in the 2 for x. Does 2 squared minus 3 times 2 plus 2 equals 0? 2 squared is 4. 3 times 2 is 6. And that checks out as well. 4 minus 6 plus 2 equals 0 as well. And so both of my solutions check out. So let's try another one. So remember, if your equation is not already in factored form, what you're going to do is you're going to factor it, and then take each of the factors and set it equal to 0. Let's try this one. So now I need to factor this so I can solve for x. But this time, instead of just having an x and an x, I'm going to have a 2x and a 1x, because that's what multiplies to get me 2x squared. This plus at the end tells me that my operations are going to be two of the same operation, and they match this middle one, so it's going to be a minus and a minus. And then my only options here are 3 and 1. And so I'm going to try it this way at first, just to see if this works out. So when I remultiply this, the 2x times the 1x gets me 2x squared. That checks out. This gets me, when I multiply 2x times negative 3, negative 6x. This gets me negative 1x. When I put those together, I get negative 7x, and that's not what I had here. I had a negative 5x. So that means I have not factored correctly. I need to go back to the drawing board and try again. So I'm going to switch the 1 and the 3. Actually, that's the way I had it. I'm going to switch the 1 and the 3. I'm going to put the 3 here and the 1 here. And I'm going to check again. Again, 2x times 1x, 2x squared. This time the outsides get me negative 2x, and the insides get me negative 3x, and when I put those together, I get negative 5x. And then the negative 3 times negative 1, that's positive 3. So now I've factored correctly. Now that I know that I've factored correctly, I take each of those factors and set them equal to 0 and solve. Here I get a solution or an answer of 3/2, and here I get an answer of 1. And so my two solutions are 1 and 3/2. And you can check that work. I'm running out of time, so I'm not going to do that. You can check that work and make sure that your answers are correct, and these are. So let's try one more. So in this one, I'm going to factor. I know I have to have an x and an x. This time I have a minus at the end. That tells me I'm going to have one of each sign. And the question is here, for this first position, is it a 1 and a 6, or is it a 2 and a 3? Because both of those multiply to get me 6. In the end here, the question is it 1 and 4, or is it 2 and 2? Because both of those multiply to get me 4. And so I'm going to tell you a good way to start is start with the values that are closest together. So I'm going to put my 2x and my 3x. Now, it might not work. I might have to go to the 1 and 6, but I'm going to try that first. And then I'm also going to try the ones that are closest together here, 2 and 2. And so when I FOIL that, I get the 6x squared. These outsides get me negative 4x. These insides get me positive 6x. And when I combine those, I get positive 2x. That's not what I have. Here I had minus 5x, so that doesn't work. Now, I could switch the 2's around, but I'd just be having the same thing. It's a 2 and a 2. So what I'm going to do next, before I try and change my first values, I'm going to switch the last ones. So I'm going to get rid of the 2 and the 2. And I'm going to try the 1 and the 4. And again, when I check this, 2x times 3x, that's 6x squared. Here the outsides get me negative 8x. Here the insides get me positive 3x. And when I put those together, I get negative 5x. Wow, isn't that nice? And in the last terms here, 1 times negative 4 is negative 4. So now that I have it factored correctly, now I take each of these and set them equal to 0. So either the 2x plus 1 equals 0, or the 3x minus 4 equals 0. In this case, my solution is negative 1/2. And in this case, the x is positive 4/3. So my two solutions are negative 1/2 and 4/3. Again, you can check this by putting it into the equation, each of them, and seeing if you get a true sentence. But I'm going to tell you, you will. So that's it. Let me know if you have questions.